talking about finding the measure of an arc that correlates to an angle being 180 degrees and a radius of a circle being 14 inches. So, here we go. Just to get a little visual idea as to what's going on. So if we have a 180 degree angle, that means our angle is rotating halfway around the circle to the other side. So there would be 180 degrees. It tells us that the radius is 14 inches, so from here, either direction is 14 inches. And the question is to find the measure of the arc, which we also know as the circumference from geometry, but now we're saying this is the arc length, the arc that is across from the angle that we're working with. So that would be the space that we're trying to find. How can you find the measure of the arc?
Well, I said the 180 equal to S divided by 14.
Okay, so he said 180 is equal to S over 14. And that formula is a formula that we talked about 2 days ago on Wednesday. It's also one of the formulas that are on the fact sheet, the trick fact sheet that you got on Monday. So an angle is equal to S over 14. Except there's one tiny little thing that we have to think about with this formula. Does anybody know what that formula kind of means, Chelsea?
Is it S in terms of rate?
So the formula is in terms of radians because this is the formula for radian measure. So Michael, you are almost there, but this 180 degrees is a degree value, and the formula only works with radians. So the formula is for radian measure. You've got to have radians if you're using the formula. So instead of having 180 degrees, Michael, that's the same value as pi. So we're going to take pi and set it equal to S over 14. Because pi and 180 are the same angle, just one's a degree, the other one's a radian. They're equivalent though. And then if you find S, because that's what the arc length is. So the arc length is the S in the formula. The R would be the radius. So S would be equal to 14 times pi. Or that's approximately, I don't remember. Anybody have that approximate value? Chelsea?
43.98.
43.98. Sorry, I totally didn't remember what that answer was. And then the units of that would be in inches. Whatever the radius is given in, it's given in inches. The arc length is a distance. It's a distance around the circle. So that would also be in inches. So it's not the angle measurement, that's radians, but it's a distance or amount of space that's taken up around the edge of the circle. So you could leave it as 14 pi inches. If you want to keep it exact, make sure you're just using the units of inches, or you could convert it to 43.98 inches by multiplying with pi. Any questions on 93? So 87 and 89 were the same formula, but you were trying to find the angle in those cases instead of using the angle to find the arc length. So the other two problems gave you numbers for the arc length and the radius, and then that number that you found was the angle. So one of the angles was 6/5. I think 87's angle was 6/5, and that 6/5 is in radians. So you don't need to do anything else with it. It's just a radian value. If you're using that formula, your answer is always in radians. Are there other questions from the homework? Okay, so today we are going to try and create the diagram that is on the front of your yellow cover. This cover sheet that was put on this packet to make it look all nice, I guess. It totally ruined my spacing. But we are going to try and create this diagram, and I'm going to show you how it's created. And also show you some patterns and ways to think about how the values kind of came from or derived from. So in your packet, if you'll turn to page, so I think 2H, 2G, yes, thanks. So your page should look like this here. So we are going to talk about a huge concept in trig called the unit circle, where most of the things that we do are going to pull on, draw from the unit circle. So eventually we'll get to graphing, word problems, all of that comes back to the unit circle. And a lot of the calculus that you'll be doing in terms of trig will all go back to the unit circle. So at the top it says the unit circle is, here we go, one of the two historical perspectives of trig. So either you can think about it in terms of the unit circle, or you can think about it in terms of those two special triangles. So those two special triangles that you had your quiz on yesterday, 30, 60, 90, 45, 45, 90, like all of trig is based off of those. Or 95% of trig is based off of that. Or it's based off of the unit circle, which we actually use the triangles to help us create the unit circle. So to kind of get you to think about what we're going to be looking at, I pulled my clock off the wall. My clock is a circle, so it's kind of nice to think about. But it says, imagine a real number line is wrapped around a unit circle with positive numbers corresponding to counterclockwise, negative numbers corresponding to clockwise. So if you look at the edge of this clock, think of this clock as having a number line. A number line literally is just that straight number line that we would label with like 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. But we're now bending that to be around our circle. It would start here. The x-axis would go from -9 to +9. The y-axis would be from 12 to 6. So it would start at 3 if I had a clock, because that's where the angle of 0 would be. And it would rotate counterclockwise, and all of these numbers would be on the edge. So that whatever time I was looking at, so if I'm using my minutes hand, it's at like 29 minutes. Wherever that time is touching the edge of the circle, there's an ordered pair that's correlated with that. Because to get to that space on the number line, we have to go over so far for x. So from the center, we go over a little bit for x, but we have to go down a distance to get to that point for y. So what we're saying is that any angle, wherever it touches on the edge of the circle, now has an ordered pair correlated with it, because we're going to plug an xy axis into the middle of the circle. So points, x, y, are still part of a circle. They're like embedded in it. So we now have this xy axis that's kind of like on top of the circle or inside of the circle. So our goal is to try and find those points, find the x and the y that would correlate with a lot of angles that would spin around our clock or our circle. Not all of them, but we can at least kind of think about some of them that are related to those special right triangles. So it says over here that the unit circle, the reason we call it the unit circle, is because the radius is 1. So this formula here is a formula for a circle. So if we have a circle's equation is x squared plus y squared equals 1. A parabola is y equals x squared. So to get it into that circle formula or format, both the x and the y terms are squared. We'll actually be talking about circles closer to the end of the year when we start talking about the conics section. So that's a different section of trig and pre-calc that we'll look at. But our unit circle always has a radius of 1. So all of the angles that we associate with will always have a radius of 1. It says that we have this real number 0. So I'm going to go on this little circle now. The real number 0 is really the angle of 0 radians. So here's my 0 radian angle. Because the radius of a circle is 1, here's my radius of 1, this angle where it touches the end of the circle has an ordered pair. Because my x distance to go across, to get to that point, I have to travel a distance of 1, since that's the radius. And then the y is 0, because the angle is just 0. It's not moving up or down anywhere. So that's how you get that ordered pair to go along with it, because you're traveling over a distance of x, to get to that point. And the unit circle has just a distance or radius of 1. It also says, since circumference is 2 pi r, so here's 2 pi r, if my radius is 1, that means our circumference is 2 pi, so 2 pi also has the same ordered pair, because 0 and 2 pi are at the same place. So that works for angle 0, but we can associate that with any angle on the circle. And that's what we're going to try and start to find. So that's what this next number or this next information here says. So if this is our angle, we would have a point T, whatever that point happens to be, as an ordered pair of x comma y. And the reason we can create that ordered pair is because we have to travel some distance for x and some distance for y to get to that point. Every time you make a point, whether you think about it or not, so if I want to plot the point 5, 4, we're really going over 5, and we're going up 4. So right here would be that point 5, 4. But technically, you're making a triangle with that point. Every point that we ever plotted, you could technically draw a triangle associated with that point. Because I'm moving over x, I'm moving up y, and I could then create a triangle connecting it to the center. So that's what we're going to try and do today. So points, special points on the circle, special angles on the circle, we're going to see if we can create a triangle so that we can get that point that correlates with the angle. So, we're going to have to do some flipping back and forth in this packet. We're going to come back to the back page to H in a minute. So if you want to earmark it, just so that you know that we're turning back to it to make it a little easier. But we are going to skip ahead to the page that has this crazy diagram on it. Right here. And again, I apologize for the way this packet was copied. I wish I could have thrown all of them away and just redone them myself. A lot of wasted paper, I suppose. So this says number 3 at the top where the staple is. This is what we're looking at. It's here. There we go. So yesterday in class, we talked about the common angles of a circle that we're going to focus on. And those common angles are all the angles correlating with our 30, 60, 90, our 45, 45, 90 triangle. I'm just going to label those angles again in degrees. So starting with degrees, we had 0 degrees. Does anybody remember what the pattern was to work yourself around the circle from yesterday, Paris?
30, 15, 15.
Right, so that's what we're increasing by to get to the next angle. So we have 30 degrees, we increase by 15 to get us 45. Increase by another 15 to get us 60, increase by 30 to get us 90. And then if you just continue adding that pattern, that gets you then those corresponding angles, similar angles to what we already have, just having a bigger number because we're in quadrant 2, quadrant 3, quadrant 4. So continue that pattern for all your degree values, adding 30, 15, 15, and then 30. So you're just spinning around the circle, moving toward the next quadrant by adding your previous angle with either 30, 15, 15, or 30 to get to the next one. So, do the angles need to be memorized? No. If you remember 30, 15, 15, 30, then you should be able to create all those angles. So you need to remember the pattern. 30, 15, 15, 30. So then the next step would be to try and get the degrees correlating with radians, because every degree angle has an equivalent radian angle. So if we have 0 degrees, we also have 0 radians. If we spin all the way around for 360 degrees, well, that also means we have 2 pi. Does anybody know what a 30-degree angle is as a radian value? Michael?
I don't know about 6.
Nice job, Michael. So if you look at all of the degree angles that are divisible by 30, and there's a lot on here that are divisible by 30, we can count with units of pi over 6, since pi over 6 and 30 degrees are equivalent, to find all the radian values that are associated with the numbers divisible by 30. So if I go to the next angle that's divisible by 30, 45 isn't, but 90 is. Because 90 is 2 times 30. If I use pi over 6 and add another pi over 6, that gives us 2 pi over 6. But what is 2 pi over 6 reduced? Chelsea? Pi over 3. So a 60-degree angle is 2 pi over 6 or pi over 3. And I'm just getting that by counting with pi over 6. So pi over 6, 2 pi over 6. So 90 degrees would be 3 pi over 6 or pi over 2. So at any 30-degree value that a number is divisible by 30 degrees, our angles are divisible by 30 degrees, I'm just going to keep on counting by pi. So pi over 6. So I have pi over 6, 120 is divisible by 30. So this is my next value of pi over 6. Now we're at 4, which reduces to 2 pi over 3. So just keep counting around all those angles that are associated with 30 degrees. 135, can I take 135 divided by 30? No. But 150 would be, how many pieces of pie are we at now? About 5? Pi over 6? Because we were at 4 pi over 6, so now I'm at 5 pi over 6. So Virginia, 180 degrees is just pi, because it's 6 pi over 6, which is just pi. 210, well, we were at 6 pi over 6, so continuing counting my pieces of pi, we're at 7 pi over 6. 240, we have 8 pi over 6, which is really 4 pi over 3. 270, we're at 9 pi over 6, which is 3 pi over 2. So a lot of these angles are really related to a 30-degree angle. Here we have 10 pi over 6 at 300, which is 5 pi over 3. And then the last one, 330, is 11 pi over 6. Because 12 pi over 6 would be 2 pi. And that's what we did when we were sketching angles. So if I had a pi over 6, my angle was 11 pi over 6, we made 6 pieces of pi on the top, 6 pieces of pi on the bottom, we counted around to get our pieces of pi. So all but 4 have radian values. And those 4 are all associated with the 45-degree angle. So that's why we had to skip over those, because that's the other triangle. So one triangle has 30 and 60, the other triangle has 45. Michael, do you also know the radian value with 45 degrees?
Yeah, pi divided by 4.
Excellent. Pi divided by 4. So now if we look at all the angles that are associated with 45 degrees, 45 plus 45 makes 90. Pi over 4 plus pi over 4 is 2 pi over 4, or pi over 2. Going to the next one, 135 degrees, if this was 2 pi over 4 at the top, we now have 3 pi over 4. Halfway around would be 4 pi over 4, well that's pi. Going down at the bottom, 5 pi over 4. 6 pi over 4 is 3/4 of the way around. And then 7 pi over 4 is 315 degrees. 8 pi over 4 is 2 pi. So you can label a triangle, the circle, by starting with pi over 6 and almost all of them but 4, so 12 out of the 16 little bubbles. You can count just with pieces of the pie and then reduce them. So again, do they need to be memorized? No. If you can remember the pattern that, like, you're just counting by pi over 6, except for the ones that split the quadrant in half, then those are your pi over 4 angles. Questions? All right, so we are going to go to that triangle, and at the top, if you want to draw yourself a neat-ish Hold on, I want to switch my triangle here. Alex, okay. This is 30 degrees, up here is 60. Here's my 90-degree triangle. So going back to the 30, 60, 90-degree triangle. A unit circle has a radius of 1, which will be most of the angles that we work with will be the unit circle. So that means that my radius of this triangle, or my hypotenuse of this triangle, is going to be 1. Because really it's going to become the radius of our circle once we plug it into the circle. Kate, if you have the 30, 60, 90, the number across from the hypotenuse is equal to what? What's that little formula? Yeah. Or I'm sorry, across from the 90-degree angle. I'm sorry.
The 8 times.
That one's this guy here. So this one would be
2.
2a, there you go. And across from the 30 is just a. So Kate, what does that mean a is? So if 2a is equal to 1, a is equal to? I know, I'm picking on you, right? What'd you say?
2.
1 over 2. So 2a is equal to 1. If we divide by 2 to get a by itself, a is equal to a half. So the side across from the 30 is 1/2. What's the side across from the 60 if it's a times the square root of 3? So what would that become if it's a times the square root of 3 and a is a half?
Square root of 3 divided by 2.
Square root of 3 divided by 2. So I'm just going to clean up my triangle here. So the hypotenuse is 1. Because it's a 30, 60, 90 triangle, the side across from the 30 is 1/2, because half of 1 is a half. The side across from the 60 is the square root of 3 over 2, because a half times the square root of 3 is the square root of 3 over 2. So we're going to take that little triangle and replicate that in our circle, because now we have a point that creates this angle, or a triangle associated with this angle. And that angle is a 30-degree angle that connects at the edge of the circle. Our hypotenuse is 1. The side across from the 30 is a half. And the side across from the 60 is the square root of 3 over 2. So if I were graphing and I needed to decide where that point would be located, we would look at the graph and say the distance for x is this space, the distance for y to get up to this point is this other space. So if you look here on my graph, the distance to get us over horizontally is the square root of 3 over 2. That's our x value, how far we would move to get over to that point. We then need to go up vertically to get to that point, and that distance is a half. So the ordered pair that goes along with 30 degrees is the square root of 3 over 2 in 1/2. Every 30-degree angle will have that point. The square root of 3 over 2 in 1/2. The other thing that's special about that ordered pair, if you look back at your triangle, you don't have to write this down, but just kind of getting you to think. Chelsea, if you have a 30-degree angle and I asked you to find the sine of 30 degrees, what two sides of the triangle would you use to find the sine of 30 degrees?
The opposite of that.
What is the opposite of this triangle? Yeah, the 1/2. The hypotenuse is? What is 1/2 divided by 1? Just 1/2. With an ordered pair, sine and cosine are attached to every value of your ordered pair. The sine of every ordered pair is the y value because it's going to be the opposite side. the opposite side of any angle is going to be that vertical distance that it takes me to get up to that point. So when we have an ordered pair, x comma y, sine is your y value. Cosine is the x. Because adjacent to any angle is your x distance that you're traveling to get out to that angle. So now, besides having an ordered pair, you'll be asked, what is the sine of 30 degrees? Well, the sine of 30 degrees is 1/2. Because of that ordered pair, the sine is the y value. Cosine of 30 degrees is the square root of 3 over 2. Because the cosine of 30 is the square root of 3 over 2, which is what you had on your quiz yesterday, but I think it was 60 degrees instead of 30. Every single problem, no matter what, doesn't matter how wide your hypotenuse is, how long it is, it'll always go back to the same ordered pair for cosine and sine. Questions? So we are going to take this point and continue graphing it, but we're going to flip on the other side and look at a family of angles. So functions have families, angles have families. Any angle that is pi over 6 will have the same ordered pair because it's the same 30-degree angle, it's just located on the other side of the circle. So this is still the square root of 3 over 2 and 1/2. Except if you're on the left side of a graph, Chelsea, you're on the negative side for x. That's the only difference with your ordered pair. So it's still a 30-degree angle, but the x has to be negative because we're on the negative side. So if I'm graphing, I'd move left, which means our x is negative. Going to another angle that has pi over 6, right here, 7 pi over 6. So we'll have the square root of 3 over 2 and 1/2. But now we have to go over and down. Left and down means they're both negative. And then the final pi over 6 angle still has the square root of 3 over 2 and 1/2. But to get to this point, we have to just move down to 1/2. So the 1/2 is negative. So I want you to go back to that 30, 60, 90 triangle that we have created. Because we're going to go to our 60-degree angle now, which is up here at the top. We're going to look at it the same way, except we now have 60 degrees. So across from the 60, in my triangle, across from the 60 is the square root of 3 over 2. That's just moving now to be the vertical side. Across from the 30 is 1/2, which is now the horizontal side. Same numbers, they just flip-flop because the location of the sides flip-flop. So my x distance to get to that point is now 1/2. The y distance to get up is the square root of 3 over 2 to get up to that point. So your ordered pair flip-flops because the location of the angle has switched. That inside angle now is 60 degrees. So label the other 60-degree angles, which means those pi over 3 angles, label them the same exact way. So we have 1/2 square root of 3 over 2, but we're on the negative side for x. Questions? So there's one leftover triangle, and that would be our 45-degree triangle. Its hypotenuse is equal to b times the square root of 2. Which means if I divide by the square root of 2, I have 1 divided by the square root of 2, which is really the square root of 2 over 2. Every 45, 90 triangle has the same exact values. So my x is the square root of 2 over 2, the y is the square root of 2 over 2. Because I'm doing the same thing to go over and up since the opposite and hypotenuse sides are this, or the opposite and adjacent sides are the same. last four angles are called our quadrant angles, where you're only moving left or right or up or down. And the distance you're moving to get you to the edge there is whatever the radius is. So for the angle of 0, I'm moving over a distance of 1 because that's the radius, and we're not going up, so that ordered pair is 1, 0. If I go directly on the other side, I'm still moving over a distance of 1, but it's negative because we're on the negative side of the x-axis. And then at the top, we're at 0, but I move up 1. At the bottom, x is 0, but we move down 1. Questions? So this is now the circle that you have on the front of your page. You now have it completed. And I want to show you how we'll be kind of applying this. So if you can go back to that earmark page. This is 2h. At the top of 2h, it tells you the definitions of the trig functions. So let t be a real number and xy be a point on the unit circle corresponding to t. That was a diagram that we were just looking at. So here's t. There's a value xy that corresponds with that point. Any point, x, y, the sign is always the y of the point, the cosine is always the x of the point. Because to travel over or to travel up, cosine is adjacent over hypotenuse. The sine is the opposite over hypotenuse. So sine is always y because that's always your vertical distance of your triangle. Opposite is always the height of the triangle. How do you find tangent using SOHCAHTOA? Chelsea? So if my letters, the variables here, if the opposite is x and the adjacent, opposite is y and the adjacent is x, the tangent would be y over x. So I can find tangent now of any angle using y over x. Just taking that two ordered pairs, that two values, and taking y divided by x. There are three other functions that were on those trig facts, and you probably were like, CSC, what the heck does that mean? CSC is the cosecant. It is reciprocals with the sign, opposites with the sign, inverses with the sign, buddies with the sign. They go together. So it's like having multiplication and division. So if the sign is y, the cosecant is its reciprocal, which means it's 1 over y. The next one is just the secant. It is buddies with the cosine. So secant and cosine are inverses, they're reciprocals, they're opposites, they're buddies. So cosine is x, secant is 1 over x. And then the last one is the cotangent. This is the one that looks like cotangent. It's buddies with the tangent. So it would be x over y instead of y over x. All right, so Grace, what page are you on? You keep flipping. You're good. What page did you? Oh, you were good. No, I wanted to see where you were flipping to. If you then look, I'm asking you to flip a whole bunch of times. Grace, you were there. I don't know what page that was. I want you to flip one more time to page 5, to this little chart here. Big chart, actually, not little. Okay, so in this big chart, and minus, we have the sine labeled as y, the cosine is x, the tangent is y over x, cotangent is x over y, the secant is 1 over x, the cosecant is 1 over y. If you are a large writer, you might want a piece of scratch paper. We're going to see if we can fill out this chart. The thing to remember is that every angle that is related with pi over 6 has the same value. So you're not figuring out the whole chart, you're figuring out a row and then repeating that row through the rest of the chart. Because in the second quadrant, your x value should be negative, and it's going to have the same exact values. So for pi over 6, the sine of pi over 6 is 1/2. The cosine of pi over 6 is the square root of 3 over 2. That's from the ordered pair that's on your circle. And you can flip to see that ordered pair. Here's where you might have to write tiny, Chelsea. You can write tiny. The tangent is taking y divided by x. So we're taking 1/2 divided by the square root of 3 over 2. If you need to do scratch work on the side, there's so many extra pieces of paper in there, that packet, because of the way it was copied. You probably could use one of those papers to help yourself reduce. Is there one right next to it? Okay, then open that up and just put your scratch work on the page right next to it. So if you have 1/2 divided by the square root of 3 over 2, that really means we're multiplying by 2 over the square root of 3. Which leaves us with 1 over the square root of 3. Does anybody know what that is rationalized? Chelsea?
The square root of 3 over 3.
So the tangent for 30 degrees is the square root of 3 over 3. And then you're just going to repeat that process for the cotangent. So instead, it's x over y, so my x is the square root of 3 over 2. The y is now 1/2. So that means flip it, multiply by the opposite, the 2's cancel, and we just get the square root of 3. The secant is 1 over x, so flipping 1 over x gives you 2 over the square root of 3, which rationalizing that is 2 square roots of 3 over 3. And then the cosecant is 1 over y. Well, if you have 1/2 and you flip 1/2, you get 2. So then if you go down to the next 30-degree angle and just write all those values down, you're just repeating these numbers. This is the square root of 3 over 3. The next one's the square root of 3. 2 square root of 3 over 3, and then 2. And then anything that has an x above it would be negative. So x is negative, anything that contains an x needs to be negative. That means the cosine, the tangent, the cotangent, the secant, all those get a negative value. Because this is quadrant 2, and x is negative. So then you would repeat that for the next pi over 6 angle. Let me move this guy up here. You'd repeat that for the next pi over 6 angle. Have an awesome weekend. I know that was a lot to take in for a Friday. We'll go over obviously more Monday and Tuesday. You'll have a tiny quiz at the beginning of class on Monday.